Okay, this is lesson 4.2, rational number representations. Our learning target, we are going to be we're going to be defining and recognizing rational numbers and representing decimals using bar notation. All right, so we kind of talked about this a little bit, but let's start by identifying what is a rational number. A rational number is any number that can be written as the ratio of two integers. Okay, so remember a ratio, you're comparing two numbers. So if you really think about this, a ratio of two integers looks like a fraction, right? So we're going to say rational numbers can look like fractions. They can look like decimals that repeat, and we'll talk about that in a moment. They can look like decimals that terminate or stop, and you guys have worked with terminating decimals. For example, 0.5, because there it stops after the tenths place here. Everything else after that is a 0. So 0.5 is a terminating decimals. Then you can also write rational numbers as percents as well. Okay, 10%. 10% as a decimal. Remember to change percents to decimals. You move the decimal 2 places to the left. So 1/10, that would be a terminating decimal. All right, and if we were to write 1/10 as a fraction, or as a ratio of two integers, it would be 1/10. Okay, so that's your percent to decimals to fractions, those conversions you guys learned last year. Okay, so rational numbers, again, any number that can be written as the ratio of two integers. They can look like fractions, decimals that repeat, decimals that terminate, or percent. And then I've given you guys some examples here. Okay, let's talk about bar notation. For decimals that repeat themselves, if I want to represent 0.3 repeating, we're going to use bar notation. So it's just a decimal with that little bar over it. You can also put the bar over two numbers, all right? And that means that 5/2 is repeating. You could also put the bar over one number, and it doesn't have to be a number in the tenths place, okay? So that's bar notation. Rational numbers can be decimals that repeat themselves, so they can, if they have that bar notation, it's going to be a repeating decimal, so it's rational. And then your terminating decimals terminate. Think about the Terminator. He ends things. So these are going to be decimals that stop. Okay, this is a terminating decimal. It doesn't continue to repeat itself forever. It stops. Everything after this, if you wanted to put a placeholder, would be a 0. So just decimals that stop are going to be your terminating decimals. All right, I'm going to go ahead and go to the next page. This is a pretty short lesson, but the big takeaway here, rational numbers are what we've been working with up until this point, all right? And we're going to continue to work with rational numbers this year, but I want you to be able to specifically identify and know why a number is rational. So just to kind of review, let's convert some fractions to decimals, because we know that rational numbers look like fractions. So 7/20 is your fraction. As a decimal, you would do 7 divided by 20, and it would be 35/100ths. Now, what kind of decimal is this? Since it stops, it's a terminating decimal. Okay, so this number is rational because it is a ratio of two integers, 7 and 20, and it's a decimal that terminates. Right, so we're identifying rational numbers and we're justifying why it's rational. Okay, let's look at decimals to fractions. Decimals to fractions. If I have 65/100ths, as a fraction, it would be 65/100. And that would simplify to 13/20. And guys, you can do this by hand to simplify and convert. You can also use your calculator, all right? That's okay. And we'll do some more calculator practice in class with this. So this is rational because this decimal terminates, and even when simplified, it's a ratio of two integers in both cases here. Okay? All right, and then repeating decimals to fractions. We are going to show you in class how to use your calculator with the repeating decimals. I'm not going to show you over the video because it's just easier to get the calculators out in class and show you. But this is a repeating decimal, okay, 0.3 repeating, and we know, because this is a common one, this as a fraction is 1/3, okay? So again, it's rational because the decimal repeats, and it can also be written as a ratio of two integers. So these are all examples of rational numbers. All right, and then I'm going to put a note on here to ask about calculator use, because we need to go over that in class, okay? Oops. Ask about calculator use. Okay, in your own words, this is how we're going to kind of close out the lesson. I want you to describe a rational number. Okay, so let's kind of summarize what we just learned in your own words and make sure to write in complete sentences. When you're finished, be prepared to share, but while we're waiting on everybody, you can go ahead and start your assignment, and that's page 57, 8 through 15.